Hi all. My name is Stano. I would like to introduce myself a little bit. I am a pre-sales solution consultant at Siemens Digital Industry Software. I'm working across Central and Eastern Europe countries, and I'm based in Slovakia. My role is to provide complete technical insight into the manufacturing operation management portfolio solutions with focus to improve quality management, advanced planning and scheduling, manufacturing execution systems, and research and development management. I have an engineering degree in manufacturing quality department, and my main experiences are from automotive and energy industries. Today I will introduce you Siemens Op Center and manufacturing operation management portfolio. Main agenda is following. I will start first with Op Center manufacturing operation management portfolio introduction with focus on consumer product goods industry. Then I will continue with Op Center execution process product introduction. And the third point is Op Center execution process scene-based demonstration for CPG, consumer product goods industry. We strongly focus on the areas of electrification, automation, and digitalization in the Siemens. Our digital enterprise approach ties together a unique end-to-end offering. In addition to our strong business units, combined offerings, we are adding value by bringing and overarching elements like MindSphere, our open IoT platform, as well as industrial communication and services. The main area of the topic today is industrial software, which is manufacturing operation management for process in consumer product goods industry. And then Siemens offers a comprehensive digital offering to help clients achieve the closed-loop digital twin. You can see from product development, from manufacturing operations management, lifecycle management, IoT cloud, and multi-experience platform. And Siemens Op Center is available to see here, and it's covering production planning, production engineering, and production execution. Now I will play the video.
On a daily basis, we all consume a large array of formulated products. Digitalization is changing everything, transforming business models and the ways products are designed, produced, delivered, and consumed. New business models in the internet age are disrupting complete markets. A company's ability to compete in the future, to exist, is dependent on its ability to evolve with digitalization. Famous brands innovate by allowing customers to customize formulations, personalize their packaging or product, tailor products and services to their personal experience. Manufacturing industry is under tremendous pressure. Consumers are becoming more health and environment conscious and require products to be healthy, safe, and sustainable. They want premium quality products and expect low prices for standard product lines. At the same time, new generation consumers are less loyal to the brands. They use social medias to promote good quality, but will also spread bad quality using the same platforms, impacting brand image drastically. Reducing the time to market. Due to fast-changing consumer demands, producers have to launch products faster, despite rising product complexity. Enhancing flexibility. Consumers want individualized products, but at prices they would pay for mass-produced goods. As a consequence, production has to be more flexible than ever before. Consistent quality. Consumers reward consistent quality by recommending product on the internet, and they punish poor quality the same way. Increasing efficiency. Today, it is not only the product that needs to be sustainable and environment friendly, energy efficiency in production becomes a competitive advantage too. Within all manufacturing processes, typically multiple departments need to collaborate and share information. A manufacturing operations management platform allows to integrate all information streams throughout all manufacturing processes in order to provide synchronization of tasks and aggregation of data. This is what we call a wall-to-wall system.
Okay, let's get some summary about today's challenges in the process industry. Especially in the CPG market, we saw a tremendous change within the last few years due to the digitalization, which is driven by the following challenges. First one is high quality demand. Quality is and always was a critical factor in the CPG industry. The second one is high cost pressure. The third one is fast changing customer demands. It means the consumers are attempting to take more care of their health and environment by making more rational product choices using new packaging designs, seasonal products only available for a short time, low fat products free from another products, and so on. Then the next one is global setup, distributed plan for regulatory and compliancy. Next very important challenge is increasing variety of products and receipts, and global setup, distributed plans, which means different locations have different cultures and habits, and so we need to learn how to differentiate product, the market, the new technology, and turn it into our best knowledge. There was a presentation of manufacturing operation management portfolio with the following group of the products. The first one was the MES. The second one was enterprise manufacturing intelligence. The third one was advanced planning scheduling. The fourth one was research development laboratory, and also quality management. And this Siemens Opcenter portfolio acts as the digital brain of smart manufacturing operation management, is composed of different components, as you can see here. What it does, what the Opcenter execution Opcenter solution can provide for customers. Starting from planning phase, from a quality point of view, there is a plan quality activities, assess design and process risk through the FMEA, for example, define communications, practices with suppliers, and create inspection and control plans. Then we have advanced planning activities, which are, for example, collect orders from ERP, analyze material availability and plant capacity, plan what to make, when, where with long-term perspective, and define materials and resources required. Of course, then we can continue with product design, production preparation, which is very important. The preliminary checks that an MES task can be identified in 5 main activities. Material checks, ensuring the right material is available. Manufacturing, ensuring the operator is properly trained and certified for task for perform. Machine, ensuring that right equipment in the right state is available and certified for us. Measure, ensuring the right process control and test data is collected within the right tolerance. Or method, ensuring the right process and process steps are followed per the bill of process. Then we can continue with advanced scheduling module, which is covering sequence of manufacturing orders to execute versus plan, optimize schedules with priorities, constraints, conflicts, and what-if analysis, synchronization, monitor execution timelines, and real-time and manage changes. The very important point is also quality execution and production coordination. In parallel, the quality system should orchestrate quality operations according to inspection plan, laboratory, and tests. And then we can continue with manufacturing data, manufacturing performance, data collection, which is very important for traceability, track and trace all products and order details, to have possibility to view as-built information, to have a full visibility for manufacturing intelligence, contextualization of this raw data, and then we can do quality improvements and continuous improvement. This is the summary what can offer Siemens Manufacturing Operations Management portfolio, as we discussed shortly about quality, advanced planning and scheduling, manufacturing execution system, and enterprise manufacturing intelligence. The next part of the agenda is Op-Center execution process, our MES product introduction. Let me start with the video first.
Siemens Op-Center execution process is the result of process industry challenges flavored with our own industry knowledge, with which we have built a strategic, configurable and extendable manufacturing platform. Siemens Op-Center execution process delivers a revolutionary concept using business process workflows to orchestrate manufacturing activities. These activities can be performed not only by operators or automation, but also by the Siemens Op-Center or even third-party software components. This enables Siemens to provide a full digital enterprise for our customers. Shop floor connectivity and orchestration is essential in process industries. With Siemens Op-Center execution process, you can configure data communication to the shop floor based on equipment templates. During execution of the manufacturing process, these equipment templates are replaced by the actual equipment instances. This mechanism provides easy process configuration and dynamic runtime execution. Siemens Op-Center execution process not only provides industry functionality, but also provides a user experience which is able to handle any industry-specific situation in any industry-specific context. This may be material movements using handhelds, master data management or shop floor orchestration for operators. In addition, it provides a unified user experience across the different modules of the Siemens Op-Center platform, providing a seamless user experience. The future of Siemens Op-Center execution process is focused on continuously providing more in-depth, out-of-the-box functionality for process industry. This further enhances the configurability and extensibility capabilities of the platform, while delivering additional detailed integrations between the Siemens Op-Center components, which enables our customers to have a full digital transformation.
As we shortly saw the video, we could get a summary about the main functions provided by Op-Center execution process MES. And these are the main functions. For example, business process modeling and notations, execution of manufacturing processes, management of complex and detailed production recipes, planning and enrichment of the production orders, tight control of production order, and so on. We have various benefits from this MES system from Siemens, and you will be able to see it during my demonstration of this current examples. Over the years, the adoption rate of MES has gradually stayed the same, even though there are consistently high percentage of companies in the planning stage of adoption. This is because the industry still takes a big bang project-based approach. By taking a platform and application approach, manufacturing companies can take a measured, incremental and layered approach to moving from legacy systems that likely include both homegrown and existing package software to the next software solutions. On this picture, we can see product lifecycle management portfolio from Siemens, manufacturing operation management group of the products, and also automation and SCADA level connectivity with our software products, which is very important that our platform is integrated, possible to integrate with automation level and also with ERP. To continue with the next slide, I would like to show you the 6 main pillars for a configurable solution for consumer product goods. So from download of the shipments until the goods receipt managing all recipient activities, then from order management until the consumption orchestrating primary production, from labeling and secondary production, from download of the shipment and goods issued managing all distribution activities, and during the testing, process compliance to achieve and to keep all regulatory compliances, and that to provide production traceabilities. All these processes are featured with the several challenges which are met by our MOM solution, as we will show in the remainder of this presentation. Together, it is providing a continuous improvement. Then, in this slide, you can see I would like to speak about integrated manufacturing operations, points of pains, business benefits for customers. First of all, there is vertical integration to connect, as I mentioned, ERP systems with automation systems. Second is optimized use of available resources. Timely and proper execution for both automatic and manual tasks, which is providing increasing efficiency. Integrate quality and production to increase product quality, product and production traceability, compliance for the regulations, processing the raw data for the KPIs of the real-time production monitoring, and analysis, so process visibility for continuous improvement. The third part of this presentation is focused on the scene-based demonstration for consumer product goods. It is MES application in this industry. There are some examples, and I would like to start with the first scene. One of the 3 top drivers for product switching for a customer is pricing, quality, convenience, number of implications, what is required from consumer product goods, be efficient, be consistent, be on time, are very important. In order to demonstrate how we can help you with we have a number of scenes examples. And our first scene is what we can call a deal with a critical deadline. So, for example, why is it important if your customers are unhappy? Research shown that 90% of unhappy customers currently will churn. You will definitely lose your customers more and more due to this loyalty, which is introduces with the lower barriers of product switching. The same study also shown that it takes 7 times more cost to acquire a new customer than to retain a current customer. And also, customer acquisition is very expensive, so it's better focus on the current customers. With this, here we have also seen an example how failing to meet customer expectation leads to customer churn, where we see the United States retailers like Walmart, for example, they lose by average $20 billion a year due to out of stock or expired product. So not being able to meet customer demand will lead to issue products which will get expired or not sold. For this reason, Walmart raised on time in food requirements, OTIF, to 95%. What does it mean? CPG manufacturing are scored by the schedule what they have to meet in the required quantity and quality. And now here we have our first scene. For me, I am representing company Coffee Stop. It is a cold brew coffee producer, and I get an order from a reseller. It can be a retailer or end customer. The reseller asked me to provide a due date, exact delivery date when he can get exact Cocorico cold brew coffee product. I need to commit binding due date, and I also need to deliver as promised towards my reseller. Before I had manufacturing operation management solution, I failed to deliver these due dates. It was a terrible pain in order to commit something which I couldn't predict perfectly, and from this reason I had customer loss and complaints or fines. From this example, you can look a bit deeper into the problem, what caused this, and the reason for this is mainly invariance in manufacturing operations. The prediction and execution is very important. It's very important to execute as planned, and also with higher lead time variance, lower customer value, for example, to avoid a customer loss. Our solutions consist out of two folds where we deliver a feasible plan, and this feasible plan will deliver with op-center scheduling solution from manufacturing operation management portfolio. Here we try to predict the times of execution of manufacturing operations on exact due dates, as we also provide op-center execution process in a way how to orchestrate any form operators when they need to execute what. And this is in order to decrease the variance of the manufacturing operations as much as possible in order to deliver as promised. So here you can see the value gain. I will show you how I do this in the next video. First of all, there is identification customer order and provide due date by scheduling. Second, follow production schedule and start order as planned. Third, perform manual operator where preparation task is scheduled. And the last one will be possible to see in the video, execute automated production as planned. Let me play the video. We are in execution process in our order management screen where I identify the orders which needs to be scheduled based on their status. So these orders I need to schedule in op-center scheduling in order to create a schedule-based information. For this, I have a number of scheduling algorithms available. Here, I use the parallel loading algorithm. I would like to increase the efficiency of my resources. Using another algorithm shows that I can have an optimized resource usage, and I can see the actual due dates which are then known into the system. These are the due dates which are need to deliver to my customer and which I can then push towards production so they can use the information in order to execute as planned. Here we see how I can easily know when they need to be delivered. Then schedule is saved and released to the op-center execution process. And everything is available, and we can see the list of them, and we can easily know when they need to be delivered. So this was first example of this video example. I will continue with the next video. As a second step, I have to follow my production schedule so I can easily retrieve the information about the work orders. I can further deep dive into operator cockpit, what is necessary to execute. I can filter work orders. I can select a start button. So by this, I execute my reservation task as planned, which shows me which materials I need to reserve a specific work order. I can scan these materials in the next page. Reserving and kit materials using preparation task. So you can put the quantity, indicate amounts, what was taken, and as a second task, I need to perform a weighing. You can select material row, start waiting. This can be manually or automatically. As a last step, I have to start execution of automation. And this I can do using my automation task, which sends all automation parameters to using our OPC UA gateway. You can select start and it will continue. This was the first example, and this concluded my first scenario. The second scenario we will see is integration of quality and the importance of integration of the quality. As an example, I show you a famous gin producer where issue by delivering products with 77% of alcohol instead of regular 40%. This recalled a single batch, but it led to a nationwide recall, and it gave worldwide press coverage. This shows how critical quality is for your brand, for your company, for the plant. And we will show you how to optimize quality in the shop floor. So I, as an employee of Coffee Store, I have to produce perfect quality product for my customers. So therefore, operators and shop floor lab technicians in the lab or at the line. And while we not have proper integrated quality, this leads to high amount cost of quality and more quality issue as we did repeated mistakes, etc. So in order to cope with the quality number of questions have to be asked. Because quality issues can raise in a full value chain of product, so we need to be able to mitigate as much as possible all quality issues. We need to ask yourself, how can we test the quality of our products? What is the cost of the quality measurements? What are the savings? Are the quality measurements what we are doing providing any reasonable effects in terms of saving money and not wasting any material, etc., etc. And typically, a CPG consumer product goods apply what we call brute force quality. Brute force quality because additional quality into production life cycle exponentially increase the cost of the production due to this additional quality test to be performed at the line. By having integrated approach, we can avoid exponential cost of quality by having digital communication between lab and shop floor. And in this way, you can integrate quality test over the full production life cycle of product, and in the way have a more incremental approach of quality. You will be able to detect quality issue much earlier, adjust your batches properly with smaller amount of waste or scrap. As I'm Coffee Store employee, operator, and laboratory or laboratory technicians, I will show you how I execute a quality test at the line by doing quality test task, which is direct in the action between OpCenter MES and OpCenter RDNL, where quality test is being configured in OpCenter RDNL and executed in execution process directly at the line, entering the results without having to switch screen. Easy identification of a sample and execution of quality test. So I will start video. Now we are in operator cockpit and we have running batch, and I will perform quality task at the line. So I need to see what I need to measure, and this is presented to me in a quality task. I need to measure the density, viscosity at the line and enter the results in the screen. This information was configured, and test results will be directly pushed to OpCenter RDNL, where they will be available for laboratory technicians. And here, I will take an offline quality test where I am instructed by work instructions how to take particular sample, and this sampling task is already creating a new identification and hence send this ID to RDNL. I can print a sample label and I can stick it to the bottle, and I bring it to the lab where the lab technicians can identify the sample and directly drill the quality test to be performed, and I can fill the results. When saving these results, I inform production about the results digitally, and they know instantly whether the result was good or not using digital channel. This is concluded my second scenario, and as a third scenario, I would like to show you value of traceability. As we know that when having a recall, there is the direct cost about $10 million, but there is not the only direct cost, but there is also indirect cost for brand and production reputation. And this 10 million of recall is not only getting your products out of the shelf, it is also huge cost on investigation on what is the issue and what is the scope of recall. These are all costs which are adding up to $10 million for direct recall costs. So also in a coffee shop, we have this situation that sometimes customers will bring a complaint of an issue with a certain product. Here is a customer service representative. I accept information come from the customer who has a certain issue, and I accept the batch number we have on our products, and with this I can verify the manufacturing data of affected batch. I can evaluate whether there is further a bigger issue or there is isolated incident. Before we had a MOM in place, this was very time consuming because information were stored, decentralized, there was not end-to-end trace, and there was very hard to retrieve all the batch records. Moreover, this was sometimes even paper-based, and it was very hard to determine which information is relevant. And traceability nowadays, this is what we see here. Traceability, how is typically done now. People are really losing line of sight, and this is very inefficient and very error prone. As it takes a lot of material manual handlings, typically a deal has been made when we create work orders ATC. But then it needs to be executed, and typically the expert is made planning in Excel other files. At the end, we can see actual performance on what we have produced. What is true here? We don't know, because there is a lot of room for error and a lot of potential for mistakes in there. Communication between the people in the factory from across the board levels to the operator, then back through the Excel documents. You can see on the visualization that it's really not good, and it can happen that there will be a lot of error during the communication to the end of the chain. And this also forms indicated already that MES, Microsoft Excel, can be most dangerous software on the planet, as it allows of easy management of data, but also there is a lot of room for errors in this Microsoft Excel, because it is all manual and all relying on people with mistakes of copy and paste, linking wrong lookup values. There is no actual governance in place, which leads to huge data integrity issue. Capturing information digitally and automatically, we have two main advantages. First of all, we tackle the inefficiency issues because information is automatically stored when, for example, a certain work order is executed, and also we have direct trace of what has been done. This digital trace can be used in order to analyze this later on in case of certain issue which is arising. At a coffee store, how we typically deal with this issue, we identify a material tracking unit using a lot which is reported by the customer. And there I used our search engine in order to retrieve the lot information. I can also further identify work order of material tracking unit using material genealogy. And using that work order, I can verify consumed material, and I see if there were any discrepancies. I will start the scenario for the video 3. Here I am again in our search engine. Using the information that customer is giving me, I can easily retrieve lot using the lot number provided. I can retrieve the material tracking units. So this is the lot, and you can see informations in material tracking unit. Using the genealogy, I can navigate forward and backward into the full production history. This history has been imported in the material, or what has been consumed, what has been produced, for example, where were samples taken, samples, genealogy. Also, I can verify the equipment history of using this genealogy. And third point, furthermore, on the material tracking unit, there is a link towards the work order. So I have this work order information available, which I can use to easily look this up. Having this work order, I can further drill down into the operations which has been executed with the work order, and I can, for instance, verify which materials have been consumed in that work order and do a verification of discrepancies. After the verifications of the discrepancies, you will have precise overview about the data inside. Okay, and with that, I would like to conclude my presentation. Thank you very much. I hope it was good for you and it will be useful, this information what I provided. Thank you very much and stay safe.